Good morning.
Good morning.
Good
Morning. Good morning.
And how's everyone today? Peachy? All right. Well, okay, so today we're going to, I don't know if you got the memo, but I'm actually going to start in chapter 2 today because we've got some visitors that may pop in. And anyway, I don't see them now, so they might be attending my other class. But anyway, so I decided I wanted to start the chapter 2, and then, maybe we'll go back into 1.8 or whatever. But I didn't want to start in the middle of it. So that's kind of our plan today. Let's see who's here. I know we've got several people out for one reason or another. Let's see, Andres is out. Desiree.
Here.
Naomi.
Here.
Raylyn.
Here.
Caitlin.
Here.
Avery.
He should be here.
He's coming.
Okay. All right. Cyrus.
Here.
Tara.
Oh.
No?
She's not here.
Okay. Jay.
Here.
Lauren.
Here.
Taylor.
Here.
Ricky.
Here.
Seth.
Here.
There you go.
Madison.
She's not here.
Okay. Kinsley.
Wait, say it again.
Here.
Doing all the work. Sierra.
Here.
Hannah.
She's not here.
Jocelyn.
She's not here.
Okay. Cottrell.
Here.
Rebecca.
Here.
Serena.
Here.
And Anna Marie.
She's not here.
Okay. All right. Okay, so Mrs. Smith, I guess Holbrook High School didn't check with you before they scheduled the air band, right?
No, they did not.
How rude of them. Anyway, but we do what we can. So several of them though did email me, so that's why I knew they were going to be gone. So I am very happy about that, and just encourage them to watch the video. Okay.
Okay, I will do that.
Thank you. All right. Well, let's go ahead and get started here. Like I said, we're going to start in on chapter 2. Does anyone have any questions, comments, concerns before?
I don't think we finished 1.8.
Yeah, I know.
Okay.
We'll finish that up on Monday. Okay. It's just because, like I said, we might have some visitors pop in or whatever. I just wanted to start a new lesson for that. So, okay. So we're going to. So chapter 2 is on the introduction to equations and inequalities in two variables. So this is mostly about a lot about graphing, equations, inequalities. And so today is just going to be an introduction to the Cartesian coordinate system. Does anybody know anything about Rene Descartes, that the Cartesian system is named after? Anybody ever heard of him? No? Anyway, it's kind of a fascinating character. If I ever had to do a report on a mathematician, he might be one that I would do. Is he was the guy that invented exponents, and this Cartesian coordinate system is named after him, Descartes. He would do a lot of his math. He'd wake up and he'd do the math in bed before he even got out of bed. He'd just be doing some math. Anyway, it's kind of funny. Anyway, well, let's just move on. Okay, so we're going to talk about the Cartesian coordinate system, graphing points, and lines, and then the couple of formulas, distance and midpoint formulas. So pretty much this entire lesson you've had before. So this will be a good review to kind of set the tone for what we do next in this chapter. All right, so we start off with an ordered pair. So what makes it an ordered pair, what that means is that the order matters of the number. So the 0.23 is not the same thing as the 0.32. Okay. So each point in the plane is identified by an ordered pair. Okay. Every point has a unique like an address. The first coordinate indicates the horizontal displacement from the point of the origin, and the second coordinate indicates the vertical displacement. So how far we go up or down. Okay. So when we graph or plot points, we figure out how far we're going to go left or right from the origin, and then how far we're going to go up or down. Okay. So now we also list the 4 areas as quadrants. Okay. Now, have any of you ever been to Seattle, Washington? Anybody? Yeah. So Rebecca, did you notice that they actually referred to the areas of the city as like quadrants, or did you pick up on that a little bit? Maybe. Anyway, it's kind of interesting. So you have really 2 number lines, a horizontal and a vertical number line, and where they intersect at 0, 0, we call that the origin. And then so those 2 number lines divide the space into 4 areas that we call quadrants, 1, 2, 3, 4, and so they're numbered counterclockwise. Now quadrant, so the origin, it's the coordinates of a point at the origin would be 0, 0. And then a point in quadrant 1 has both terms positive. So like the 0.31, you would measure over 3 from the y-axis to the right, and then up 1 from the x-axis, so the 0.31. The point -2,2, you would go to the left 2, and then up 2. That's a point in quadrant 2. -1, -4, for example, we'd go 1 to the left, and then 4 down. And then quadrant 4 would be +4, -2. So a point in quadrant 4 would have a positive x-axis and a negative y-axis. Okay. Now, so let's just say if I had, let's just say if I had this, whoops. Okay, so let's say I had this point, gave it away. Let's say I had, wait, why is it, okay, so what's the coordinates of that point right there that I just did? Let's ask Naomi. What's the coordinates of this point right here?
-5, 0. Nope, 0, -5.
Okay.
Oh,
So
-5, 0. Yeah, sorry.
okay.
-5, 0.
You're right. The first, yeah, -5,
Okay.
0. 0, -5 would be right here. Okay. So whereas this one, whoop. So negative 5, 0. So the first coordinate tells you how far to go left or right. The second coordinate tells you how far to go up or down. Okay? All right. Now, this, if a point is on one of the lines, then we say it's not really in a quadrant. It's on the boundary. It's a point on the x-axis or the y-axis. Okay. All right. So, let's see. Okay. Now, we use parentheses to denote ordered pairs, like negative 2, 5, but we also use parentheses to show intervals. And unfortunately, it's the exact same notation. So whether we're talking about the interval or a point, you have to use the context. Okay? So when I invent my own math system, I'm going to come up with a different way of writing one or the other. Okay? All right. Okay. So I would like you to, let's go ahead and do practice 1. So it says plot the following pairs on the Cartesian plane and identify which quadrant they lie on or which axis they lie on. So do those 3 problems there. All right, Jay. So the first point, what quadrant does it lie in? Negative 2, 4.
That's in quadrant 2.
Quadrant 2 is correct. All right, Desiree, how about the second one? What quadrant does negative 6 lie in?
Quadrant 3.
Quadrant 3. And then the last one, Madison.
She's not here.
Oh, sorry. All right, Ricky.
Wait, for C,
Yes.
that one is on the boundary.
Okay, which axis? The x-axis or the y-axis?
The Y.
The y-axis, that's right. Okay, so let's take a look at where the graph is here. Let's see, wait. Oh, each point is identified by an ordered pair. Okay, here it is. Okay, so there's your 3 points. Here, here, and here. Okay. Any questions on that? Let's see. Let me go ahead and. Let's go ahead and put those up there. So negative 2, 4. Right there. And so that's in quadrant 2. Negative 6, negative 6. Well, it's not showing us that one. And then 0, 5. Okay. Huh. So 0, you don't need a negative there. Okay. All right. So any questions on any of those? All right. Well, here's the deal: is that the quadrant system can be very helpful in determining, like, reading maps or navigation and so on. As a matter of fact, have any of you ever lived in a town that where the town is laid out according to a coordinate system? Any of you lived in a town? Well, I will tell you this, is that I know Joseph City used to be laid out in a coordinate system, but then it actually, like a lot of towns, they actually, when 911 came about, that they wanted them to rename some of the streets. So if you go back in the history of Joseph City, that they, but before they had street names like Randall or Porter or whatever, they had numerical streets, and so it was laid out like that. Holbrook, the way that they did it is, instead of, let's see, they have like 1st, 2nd, 3rd, 4th, 5th Avenue, and then the cross streets they did numerically. So like the street names are alphabetical. So like Erie comes before Florida, and so on. And so there's a little bit of a rhyme and reason. But when I first lived in Utah, the streets were laid out on a grid system. And so all I had to do is tell someone my address, and they could immediately find where it was. So when I lived in Provo, going to college, 1047 West, so you'd go west 10 blocks, 2100 north. And so it was like a coordinate system. And so all you had to do, just like knowing where the points were, you could just tell someone your address and they could find it, which was great. See, you guys don't know what it's like to not have GPS and to drive around lost looking for hours for places. But when I moved to South Carolina, the street that I lived on wasn't even on a map. I mean, there was like no rhyme or reason to how it was organized. You tell someone your address, and if you didn't give them more information than that, they probably couldn't find it. Okay? And I thought, God, why couldn't all these streets have been laid out by Brigham Young? Because where they make sense. And so, anyway, that's kind of the idea here of the coordinate system, is so that every point has a coordinate, and every coordinate has a point. Okay? All right. Let's see. All right. So now the graph of an equation is a plot in the Cartesian plane of all the points on the graph. Okay? So you get all the points that satisfy the equation, and then you connect the dots, and if it's linear, then they'll form a line. All right, so there's different ways to plot graphs, okay? And so the first way, and probably the most basic way, whenever you're like, when we get into trig, when we get into calculus, the most basic way to plot a line or a curve that you have no idea what it looks like is you plot points, okay? You plot points. Or like if you're a scientist and you're plotting data, then you plot points to determine, is that linear or is it quadratic? What is it? Sometimes you don't know. Okay. So let's start with a graph. Okay. So what you do, let's say we have this right here. So what you can do is you make what I call a T-chart. Okay, because if you start off, it looks like a T. And then you have X and Y in there. Now, what you do is you pick any value for X you want. Sometimes you can be judicious in your choice of X. But then what you do is for each value of X, you figure out what Y goes with it. All right? So let's say if you plug in, you're going to plug in here. So like, let's say if we wanted to plug in 1, then you plug in 1 for X and then solve for Y. So 2 times 1 minus 5Y equals 10. Okay, and you solve that for Y and you get Y equals negative 8/5. Okay, so that would be a point in your graph, in your T-chart. Now, sometimes there's numbers that might be easier to plug in. Like 0 is a good one. 0 is if you plug in 0 for X, see, then this will go away and you can do that in your head. Negative 5Y equals 10. And so that would mean Y is negative 2. Now, usually we just sort of plug in for X and figure out what Y is. But you could also plug in 0 for Y and figure out what X is. So if you plug in 0 for Y, then this goes away and you get 2X equals 10. You can do that in your head and get X equals 5. Okay? Now, how many points do you need to get a line? 2. But why would you want to do at least 3?
Because if it's like a parabola, you have to know like where the curve is and stuff.
Okay, great. Okay, so all right, now let's talk about that for a second. How do I know that this is a line and not a parabola? Just looking at the equation.
Say it louder.
There's no squared term.
There's no squared term. Very good. So actually, if you know ahead of time, looking at it, oh, this is a line, that really helps. So now let's go back to my original question. Let's say we know it's a line. Why do I still want to graph at least 3 points? Because in geometry, we know 2 points determine a line. So why do we want a third point?
So you know you did your math right when you were plugging stuff in.
Yes, that's exactly right. Because if your 3 points, if you're graphing a line and your 3 points form a triangle, then guess what? You messed up. Okay? So they should be all collinear. They should form a line. Okay? So then you come down and you graph the points. Just like what we did before. Connect the dots, extend the line, put the little arrowheads on them, and boom. Okay? All right. So I want you to do practice 2A, and I want you to make a little T-chart here. You can plug in any points you want. Plug in any values for X or Y. Plot at least 3, and then connect the dots. All right, Sierra, like you to draw me that line in the air when you're done. Okay, all right. All right, there you go. Okay. Now, these are the points that I did. Okay. Yours might not be exactly the same, but it doesn't matter. At whatever points you got, we should all get the same line. So as it comes up and goes down, we should all have the same line. All right. Any questions on that? All right. Good job. All right, rather than solving a new equation each time you substitute a value, it is more efficient to solve for a variable first. Maybe some of you did this already. So instead of like here, x minus y equals 4, it's easier if you get one of the variables by itself. So solve for one of the variables. So here if I add y to each side, I get x equals y plus 4. And so now, here, I want to pick different values for y, and then I just add 4 to it to get x. So see, that's much more efficient. So negative 1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, and then I connect that, or I graph those points, connect the dots, and I've got it. Okay. All right, now, so, and that works even with this one. Now, because this one has a squared term, it's not going to be a line. So you might even graph more than 3 points when you know it's not a line. Does anyone know what this is when the y is squared?
It's a parabola.
It's a parabola. Very good. Very good. Okay, let's see. Okay, do you know, Lauren, do you know which way the parabola is going to open? Up, down, left, or right?
Yeah, I don't remember how to tell that.
Okay. Does anyone know?
Is it down because the y is negative?
Okay, that's the right thinking. Except, see, if the x squared were negative, then it would open down. But when the y is squared, it opens left or right. Okay, that's a good thought. But anyway, the fact that you know that it's a parabola is going to help. So I would suggest you graph it. You in a situation like this, do at least 4. So here again, I solved it for x. You can solve it for x or y. So if you solve for x, then you're going to want to pick y values. Okay? So I like to pick small values, and I always like to pick 0. And it's usually good to pick some positive, some negative. Okay? And so then I would do 3 minus, negative 2 squared is 4. So 3 minus 4 is negative 1. 3 minus 1 is 2. 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 4 is negative 1. So if you solve for the variables, you can do these in your head a lot. And so then you go and you graph those points, connect them, and this one opens to the left. Now, how you could know that, Lauren, is if you solve it, when you solve it for x, if it's the y that's squared, it opens left and right. And if it's the y is negative, it opens to the left. So if the squared term was positive, it would open to the right. Okay? All right, so go ahead and try practice 2B. Okay, so Anna, what kind of shape is this one going to be?
Ina's not here.
Oh, Ina's not here. Sorry. All right, Kinsley. What shape is this graph going to be?
A parabola because x is squared.
Yes. And which way will it open?
Left and right, correct?
Nope, not in this one. Because, see, the left and right ones are when y is squared.
Yeah.
But in this one where it's x that's squared, it opens up or down. Now, do you know which way it will open, up or down? It'll open up. Because once you solve it for y, then the x squared is positive, so it opens up. Okay? All right, keep going. So again, on parabolas, I would probably graph at least 4 points. All right. Okay, so that's what I've got for a graph. Actually did 5 points. So it's a parabola going up. Is anyone having trouble getting that parabola that'd like me to go through it in more detail? Okay. All right, next. The distance and midpoint formulas. All right, so the distance between 2 points on the plane is found by, and here's the formula, d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, now some books will actually have the x1 and x2. They'll have, in the formula, they'll have these two reversed and they'll have these two reversed. Can someone tell me why that doesn't matter? If it's x1 minus x2 squared or x2 minus x1 squared. Why does the order not matter? Yes. Lauren, I can tell you're about to say something really super smart right here.
Because distance is absolute value.
Okay. And how does that show up in the formula?
Is it because like a negative number squared is like positive?
Yes, very good. Okay, so you both actually said something really smart there. So Yeah, because when you square x1 minus x2 or x2 minus x1, you'll get the same thing. So the order that you write down the points doesn't matter. And the reason why that's true is because distance is an absolute value. It's always got to be positive. So just applying the formula again, so it doesn't matter which point you have be the x1, y1, and which one you be x2, y2. It doesn't matter. You just plug it in. So d is equal to the square root of, so -4 minus a -7 squared plus -2 minus 2 squared. And so then, watch the signs here. -4 plus 7 is 3. -2 minus 2 is -4. You square each of those. Add them up. Take the square root. And so it's just 5. So notice that in the formula, it's not, let's go back. It's not plus or minus. Because like Lauren said, distance is always positive. Okay? So the answer here would be 5. Okay? All right, so go ahead and do practice 3A, please. Wait. Look up here for just a second. Everybody look up here. Okay? This is what, I want you to learn the formula because it's important to learn formulas, but let's say you're taking a quiz or a test and you forget the formula, you can't find it, whatever. Then this is what you could do, is you could graph those points. You could graph those points, make a triangle, and then use the Pythagorean theorem. Because the distance formula is actually based on the Pythagorean theorem. Okay? All right, well, go ahead and do the practice problem here. All right, Cottrell, when you've got it.
Oh, the distance I got was 40 square,
Square root of 40?
yeah,
Square root of 40?
Yeah.
Okay. All right. So now, square root of 40 is a good answer, but not a great answer. And I'll tell you why. Because the radical is not simplified. Because if there's ever a perfect square factor, like 40 is 2 times 2 times 2 times 5. So you could break 1, 2 out and make it 2 radical 10. So if you can, I want you to simplify the radicals, always. Okay? The other thing you could do is just put in square root of 40 into your calculator and give me a decimal approximation rounded to 3 decimals. So 6.325. Okay? So is that all right, Cottrell?
Yeah, thank you.
All right. Any questions on that? Anybody want me to go through it in more detail? Okay. All right, the midpoint formula. The midpoint between 2 points on the plane is found by m equals, okay, so what you do is you average the 2 x coordinates, add them up and divide by 2, and then average the 2 y coordinates, add them up and divide by 2. So this formula is pretty straightforward. See, if I want the midpoint of these two, I take 5 plus -1 divided by 2, 1 plus 3 divided by 2. So here I'm going to get 4 divided by 2 and 4 divided by 2, so it'll be 2, 2. Now, if you end up with when you add them up, if you get an odd number, so let's say instead of 4, I got 5. Well, 5 divided by 2, I can either leave that as 5 halves or do it as 2.5. So decimal or fraction is fine. Okay? All right, so go ahead and do practice 3B, please. All right, so Ricky, when you got it?
Is it 4.5 and 5.5?
4.5, 5.5. Oh, okay. So let's see. It's 3 plus a -6. So let's see. Yeah. So when you add those, you don't get 9. You're gonna get -3. So -1.5, 5.5. So just watch the signs on that. Okay, any questions on that? All right. Now, to graph an equation where you have high exponents, decimals, or fractions, to do that by plotting points would be very tedious and not very accurate. So that's a case where we would want to use the graphics calculator to graph that. Okay? So I want to go through the steps on how to graph something like that on the calculator. Okay? So suppose we have an equation with decimals or whatever. Okay? If you want to, you can get rid of the decimals. Now, you don't have to, because the calculator likes decimals just fine. Okay? But what you do need to do is you need to solve it for y. You need to get y by itself. So you can leave it as the decimals, but either way, you got to get the 2y by itself by subtracting -4x here, and then divide by 2. And so you have to have it solved for y. Then you put it into the y equals, and then press graph. So the main thing is, no matter if you've got x to the 4th or whatever, you have to have it solved for y. Okay? So go ahead and try practice 4, please. Wait, was that the same thing? All right. So I guess I did the same one as a practice problem. So anyway, so that's your line right there. Anyone have any trouble putting it in the calculator? You want me to do another example, or everybody okay with that? Any issues with the calculator at all? All right. Well, let's go ahead and I want to just show you that the kind of the more complicated one in this right here. Let's say we wanted to do that one. Okay. So you might just practice with me here for a minute and just put that one in there and see if you can see what it would look like. Okay. All right. So, whoops. So we'll have y equals 0.1 x to the fourth. And then you want to arrow down. Minus 2.2 x squared.
How did you put x to the fourth on there?
You use the little caret, and then it'll move up, and then you type in the 4, and then you move over, use the arrow to go down.
Okay.
Now, for the squared, you can just use the squared key. Okay. Plus 2.4x. Plus 4.5. Okay. And then when you press graph, there we go. Okay. The only thing I don't like about this graph is how it cuts this off at the bottom. So what I'm going to do is lower my y min to make it go down farther. So if I go to window, right now my y min is at -10. Let's go down to like -15. Then press graph. Let's see if I see it all now. Oh, still not seeing it. So maybe go down to -20. I mean, you could probably fake it. You probably could know, if you had to do a rough sketch of it, you probably know enough. But when I'm seeing a graph, I like to see all of it. I don't want to see it cut off. Okay? So there you go. All right, any questions on that? Okay, so I was going to go back and do a little bit on 1.8, but I'm not feeling it. So I'm going to finish 1.8 on Monday, and then we're going to go on to 2.2. Okay? Any questions, comments, concerns before we call it? All right, well, enjoy your lunch, enjoy your day, and I hope you all have a great weekend. Okay? We'll see you.
See ya. Thanks, Mr. Strong.
You bet.